Right now, as you are watching this, a piece of ice the size of Florida is cracking apart at the bottom of the world, and scientists say it could break loose sometime this year. This is not a slow, boring melt happening over centuries. This is a fast, violent crack-up that experts did not expect to see this soon. A glacier so dangerous that scientists gave it a nickname most of them hate to say out loud, the Doomsday Glacier, sitting on ice more than 6,000 feet thick, holding back enough water to reshape coastlines around the entire planet. Before we go further, hit subscribe so you do not miss the moment this ice shelf actually breaks, because when it happens, it will happen fast, and we will be covering it live. Quick question for you. If you found out a piece of ice bigger than your whole state was cracking apart right now, would you want to know immediately, or would you rather not think about it? Drop your answer below. Now let us get into what is actually happening down there. Thwaites Glacier sits in West Antarctica, one of the coldest, most remote places on Earth. It is roughly the size of Florida, which means if you tried to drive across it, you would be driving for hours and still not reach the other side. In some places, the ice is over 6,000 feet thick. Picture the tallest buildings in the world stacked one on top of another, and you still would not reach the bottom of this ice. For most of human history, this glacier just sat there quietly, doing what glaciers do, moving a tiny bit every year, locked in place by cold and by ice. But over the last few decades, something changed. Warm ocean water started creeping in underneath the glacier, right where the ice meets the ground below sea level. That warm water has been eating away at the ice from underneath, like a slow burn nobody could see from the surface. To understand how serious this is, it helps to compare Thwaites to something that already happened once before, on a smaller scale, a couple decades ago. Back in 2002, a different ice shelf called Larsen B sat quietly along the coast of a different part of Antarctica for thousands of years. Scientists were watching it, but nobody expected what came next. In just about 5 weeks, a chunk of ice roughly the size of Rhode Island simply shattered into thousands of icebergs and disappeared into the ocean. Researchers who studied it afterward described the speed of the collapse as something that genuinely shocked experts who had been tracking it for years. Larsen B collapsed so fast partly because warm air had been sitting on top of it for a long stretch, weakening it from above, while meltwater pooled on its surface and worked its way down into cracks like a wedge splitting wood. Thwaites is not identical to Larsen B. It is far bigger. It holds back a much larger river of ice behind it, and the forces attacking it are coming mostly from below instead of from the surface. But the lesson from Larsen B still applies here in an important way. Ice shelves that look solid and stable from the outside can hide serious internal weakness for years, right up until the moment they simply do not hold anymore. Here's the part that makes Thwaites different from other glaciers. At the front of it, there is a floating shelf of ice, kind of like a giant icy dock stretching out into the ocean. Scientists call this the Eastern Ice Shelf. It is not just decoration. It acts like a doorstop, a brake, holding back the massive river of ice behind it from sliding into the sea too quickly. Think of Thwaites like a huge, shaken-up soda bottle, and that ice shelf is the cap. As long as the cap holds, the pressure stays somewhat controlled. But scientists have now found deep cracks spreading across that cap, and those cracks are not slowing down, they are speeding up. Just to put the size of this ice shelf into perspective, imagine a school bus is about 40 feet long. You could line up more than 5,000 school buses end to end and still not cover the width of this single ice shelf. Now imagine that entire lineup of buses sitting on top of ice thick enough to bury a 40-story skyscraper, and you start to get a real sense of the scale we are actually talking about here. Let us pause here and give you the plain truth about how this actually breaks, because the science is simpler than people think once you strip away the scary words. For years, most scientists believed the ice shelf was mainly being destroyed from below, melted by warm ocean water like an ice cube left out on a warm day. That explanation made sense, and it was partly true. But newer research changed the picture in an important way. Researchers studying the ice shelf pulled together 2 decades of satellite images and on-the-ground data, and what they found surprised even them. The ice is not just melting from underneath anymore, it is tearing itself apart from cracks forming on the surface and inside the ice. Imagine a windshield with one small chip in it. At first, nothing happens, but once that chip starts to spread into a crack, every bump in the road makes the crack longer, until the whole windshield gives way. That is basically what is happening to this ice shelf, just on a scale thousands of times bigger. As the cracks spread, the ice starts moving faster, and that faster movement creates even more cracks. Scientists call this a feedback loop, which just means one problem is feeding another problem, over and over, in a cycle that gets worse each time instead of better. In the middle of the ice shelf, ice that used to creep along at under 2 meters a day is now moving nearly 3 meters a day. That might not sound like much, but for a slab of ice this size, that is a dramatic speed up in just a few years. Give this video a like right now if you are the kind of person who wants to understand the real science, not just the scary headlines, because we are about to explain why this matters for people who live nowhere near Antarctica. So why should anyone outside Antarctica care about a crack in the ice at the bottom of the world? Because Thwaites Glacier alone holds enough ice that, if it fully melted into the ocean, global sea levels could rise by more than 2 feet. 2 feet does not sound dramatic until you picture it in your own town. 2 feet of extra water during a storm surge is often the difference between a flooded street and a flooded home. It is the difference between a beach town keeping its beach or losing it for good. And Thwaites does not act alone. Scientists have warned for years that this glacier acts like a cork in a bottle for a much larger section of ice behind it, ice that could add many more feet of sea level rise if it were ever fully unleashed. One senior researcher who has studied the glacier for decades put it simply, saying that if Thwaites were to collapse, it would likely drag much of West Antarctica's ice along with it. That is not a small claim from a random source. That is a warning repeated across major research groups tracking this glacier for years. Right now, communities are already feeling smaller versions of this problem. Coastal cities from Miami to Jakarta to parts of the UK already deal with regular flooding during high tides and storms, flooding that used to be rare and is now becoming routine. Engineers in some of these cities are already raising roads, rebuilding seawalls, and redesigning drainage systems because the water is already creeping higher than it used to. Look at a city like Jakarta, the capital of Indonesia for many years, where parts of the city have sunk so low that some neighborhoods already flood during ordinary high tides, no storm required. Government planners there have discussed moving the entire capital to a different island, partly because of this exact problem. Look at Miami, where local governments have spent hundreds of millions of dollars raising roads and upgrading pumps just to keep ordinary rainstorms from turning into flash floods during high tide season. These are not future problems from a science fiction movie. These are present-day construction projects happening because of water levels that have already crept higher over the past few decades. Now stretch that same pressure forward a few decades, add in a possible collapse of Thwaites and the ice behind it, and you start to see why researchers use words like doomsday in the first place. It is not because ice melting sounds scary on its own. It is because the number of people living within a few feet of current sea level around the world is measured in the hundreds of millions, spread across nearly every continent, from Bangladesh to the Netherlands to the eastern coast of the United States. This is exactly why this glacier is not studied by just one country working alone. Scientists from the United States and the United Kingdom formed a joint research program years ago specifically to study Thwaites together, pooling ships, aircraft, underwater robots, and satellite time that no single country could easily afford on its own. That kind of international teamwork is rare in science, and it happens here because everyone involved understands that this glacier is not just a regional issue. It is a shared risk for coastlines on almost every continent on Earth. Comment below if you live anywhere near a coastline, even a lake. We would love to know if you have noticed water creeping higher over the years where you are, or if your area has felt untouched by any of this so far. Now, let us be completely honest with you, because this channel is not here to just scare you for clicks. There is a lot we still do not know for certain, and pretending otherwise would not be fair to you. Scientists are very confident the eastern ice shelf is fracturing and weakening. They are very confident it is likely to break apart, possibly within this year or the next couple of years. What they are not fully certain about is exactly how the breakup will happen, how fast it will unfold once it starts, and exactly how much it will speed up the glacier behind it. Some researchers are more cautious than others. A number of scientific models studying this glacier still do not show a guaranteed, unstoppable runaway collapse happening immediately. Instead, many experts describe this as the likely loss of an important safety break, not the instant collapse of the entire glacier. A full disappearance of Thwaites, if it ever happens, would likely unfold over many decades, possibly longer, not overnight. So no, your house is not going to be underwater next month because of this one crack, no matter what a scary thumbnail somewhere might suggest. But the direction things are heading is very clear, and that direction is not good, which is exactly why serious researchers keep returning to this glacier year after year instead of moving on to something else. This honesty matters because so much information online exaggerates events like this into instant disaster, and that kind of exaggeration actually hurts people. It makes real warnings sound like empty noise after a while, and it makes people tune out the next real warning when it actually matters. We would rather tell you the truthful, complicated version, because you deserve to actually understand what is happening, not just feel scared by it. Let us walk through what actually happens step by step if this ice shelf does break apart this year, because that is very different from the glacier itself vanishing overnight. First, the shelf fractures into large sections and drifts away as icebergs, some of them potentially large enough to be tracked by ships and satellites for months afterward. Second, with that floating break gone, the land-based ice behind it starts sliding into the ocean somewhat faster than before, since there is less resistance holding it back. Third, that faster sliding adds to sea level rise gradually, added on top of the sea level rise already happening from other melting ice around the world, and from ocean water simply expanding as it warms. None of these three steps happen in a single dramatic afternoon. They happen over years and decades, which is exactly why scientists can warn us this early in the first place. If this kind of honest, no-drama breakdown is something you want more of, subscribing helps us keep making it, especially since we will be tracking this glacier closely as new updates come in throughout the year. Let us go back to the story, because once you understand what is cracking and why, the next question almost answers itself. Scientists have watched this ice shelf for over 20 years, using satellites that can spot changes down to a level of detail most people would not believe possible from space. Early on, the fractures were small, scattered, and mostly harmless looking, more like hairline scratches than serious damage. Then, starting around 2016, something shifted. The cracks began spreading and deepening much faster, especially during a certain time of year in Antarctica's spring, when temperatures rise just enough to loosen things up. By 2020, large gaps had opened up in the ice, gaps filled with a slushy mix of ice chunks and debris, almost like a cracked bone that is not fully healed and keeps reopening under pressure. Around the edges, sea ice that used to help anchor the shelf in place started disappearing too, which let part of the shelf detach from an underwater ridge that had been holding it steady for years. For a long time, this slow buildup mostly stayed inside scientific journals and research conferences, noticed by experts but not by the wider public. It took repeated satellite passes, year after year, comparing old images against new ones, before the pattern became impossible to ignore. That is often how the biggest environmental warnings actually work in real life. They rarely arrive as one single dramatic headline out of nowhere. They build quietly in the background for years, through unglamorous, repetitive measurements, until enough evidence stacks up that scientists feel confident enough to speak plainly about what they are seeing. This is the moment researchers realize their earlier assumption was incomplete. It was not just about melting from warm water underneath anymore. The ice shelf was actively tearing itself apart from within, and that tearing was now outrunning the melting as the bigger threat. That is the twist in this story, the correction scientists had to make once the newer data came in, and it is a good reminder that science is not about being right the first time, it is about being willing to update the answer when better evidence shows up. One of the researchers behind this discovery described the situation bluntly, saying the last remaining piece of ice shelf in front of the glacier is poised to disintegrate, and that while nobody knows exactly how it will break up, everybody studying it agrees that it is definitely going to happen. When a scientist who has spent decades studying something that carefully uses the word definitely, that is worth paying attention to. Here is the question almost everyone thinks about the moment they hear a story like this, and we are not going to dodge it. Is this connected to other disasters happening around the world right now? Is the planet's ice just falling apart everywhere all at once? The honest answer is more nuanced than a simple yes or no. Antarctica and the Arctic have both been losing ice at a faster pace than they did just a few decades ago, and that faster pace is well documented through satellite measurements, not guesswork. But different glaciers and ice sheets behave differently depending on their location, their shape, the water temperature around them, and the shape of the ground underneath them. Thwaites is considered especially vulnerable because it sits on ground that slopes the wrong way, meaning the land under the ice actually gets deeper as you move inland, so once warm water gets underneath it, it is harder for the glacier to stop retreating on its own. So is this getting worse over time? Based on the actual data collected over the last several decades, yes, the trend line for ice loss in this region points in one direction, and it is not the direction anyone wants. Is every single glacier on Earth doomed to collapse the same way Thwaites might? No, that is an oversimplification that does not match how these systems actually work. Could a version of this happen in other vulnerable ice regions? Scientists studying Thwaites have said the fracture patterns they are seeing here could serve as an early preview for what other unstable ice shelves around Antarctica may eventually experience too. Right next to Thwaites sits another glacier called Pine Island, sometimes nicknamed its twin because the two sit side by side and share a lot of the same warm water flowing underneath them. Pine Island has already lost large chunks of its own ice shelf over the past couple decades, breaking off in pieces the size of small cities. Researchers tracking both glaciers together have noticed that when one speeds up, the other often follows a similar pattern not long after, since they are connected underground through the same bedrock and affected by much of the same ocean water. That connection is exactly why scientists study this whole region as one interconnected system instead of looking at a single glacier in isolation. At the same time, other parts of Antarctica, particularly large sections of East Antarctica, have stayed far more stable over this same stretch of decades, in some spots even gaining small amounts of snow and ice. That difference matters because it proves this is not simply the entire continent melting all at once in some uniform way. It is specific regions, sitting on specific types of ground, facing specific ocean currents that are under the most pressure right now. West Antarctica, where Thwaites and Pine Island sit, happens to be ground zero for nearly all of that pressure. If you have made it this far, you clearly care about getting the real picture instead of just the scary headline. So go ahead and subscribe if you have not already, because we will be covering the moment this ice shelf actually gives way, whenever that turns out to be. Let us talk about what this means for where you live, because that is probably the question sitting in the back of your mind this whole time. If you live far from any coastline, high up in elevation, the direct flooding risk from sea level rise is genuinely low for you personally. This is not a story that means water is about to reach your front door no matter where you are on Earth. But if you live in or near a coastal city, or you have family in one, this is worth paying real attention to, not out of panic, but out of preparation. Sea level rise does not usually show up as one dramatic wave crashing through a city. It shows up gradually, as higher high tides, as storm surges that used to stay in the streets now reaching further inland, as flood insurance costs slowly climbing, and as infrastructure that used to handle storms just fine starting to struggle. This is also where we want to give you something useful instead of just information to worry about, because knowing facts without knowing what to do with them does not help anyone. If you live in a coastal area, start by actually checking your region's official flood risk maps, which many local governments now publish for free online. Knowing whether your home sits in a flood zone changes how you plan for storms, for insurance, and for emergencies. Keep an emergency kit ready if you are in a flood-prone area, including water, a battery-powered radio, copies of important documents, and a plan for where you would go if evacuation was ever needed. If you live inland, there is still something meaningful you can do, and it is simpler than people think. Support and pay attention to coastal infrastructure planning in your country, because these projects, seawalls, better drainage, updated building codes, protect not just coastal residents but also the broader economy that inland communities depend on too. Staying informed through reliable science sources, not panic-driven headlines, is genuinely one of the most useful things any regular person can do, because informed communities make better decisions when it actually matters. A few more simple steps are worth mentioning here because preparation always beats panic. If you are buying or renting a home near a coast, ask directly about flood history and flood insurance costs before signing anything, not after. If you already own property in a flood-prone area, look into elevation certificates and talk to a local expert about whether small upgrades, like better drainage around your foundation, could reduce your risk. Follow your local weather service for storm surge warnings during hurricane season or major storms, since storm surge, not just rainfall, is usually what turns an ordinary storm into a genuine emergency. None of these steps require you to be an expert. They just require a little bit of planning done ahead of time, while the water is still calm. It is also worth teaching kids in your life the difference between weather and climate, since that single distinction clears up a huge amount of confusion people carry into adulthood. Weather is what happens outside your window this week, a rainy Tuesday or a sunny weekend. Climate is the long-term pattern measured over decades, the slow trend that tells scientists whether ice sheets like Thwaites are gaining or losing mass over time. Understanding that difference early helps the next generation read news like this with a clearer head, instead of confusing one cold winter with proof that nothing is changing, or one hot summer with proof that everything is collapsing at once. If you know someone who lives right on the coast, maybe send this to them, not to scare them, but because understanding what is actually happening to this glacier helps people make smarter, calmer decisions instead of panicked ones later. Back to Antarctica, because there is one more piece of this puzzle that puts everything into perspective. Scientists are not just watching Thwaites from computers and satellites. Teams have physically drilled into the ice, placed instruments deep inside cracks, and sent equipment underneath the ice shelf itself to measure the water temperature directly at the point where ocean meets glacier. This is some of the most extreme, difficult fieldwork happening anywhere on the planet right now, done specifically so predictions about this glacier are based on real measurements, not just computer models guessing from a distance. To reach this glacier at all, research teams fly for hours across an empty white landscape, land on ice runways, then live for weeks at a time in tents in temperatures that regularly drop far below anything most people will ever experience. From there, they use heated drills to bore holes thousands of feet down through solid ice, sometimes taking days for a single hole, just to lower a small torpedo-shaped robot into the freezing water underneath the glacier. That robot swims along the underside of the ice, taking temperature and salt readings every few feet, building a map of a place no human being has ever physically seen with their own eyes. Every single one of the numbers we have shared with you tonight came from research like this, gathered at real physical cost and real physical risk by people who have chosen to spend their careers in one of the most punishing environments on the planet. What they have found down there paints a strange, almost unsettling picture. Warm water does not just quietly melt the ice in a steady, predictable way. It swirls in massive underwater eddies, some of them stretching for miles, twisting and mixing with colder meltwater in ways that create turbulence, which is just a science word for churned-up, chaotic movement. That churning actually pulls in even more warm water, which melts more ice, which creates more churning. It is another one of those feedback loops we mentioned earlier, except this one is happening in near total darkness, thousands of feet under the ice, in one of the most hostile environments on the planet. One ocean scientist involved in this research described the discovery as revealing a feedback loop that could become even stronger as the planet continues warming. That single sentence carries a lot of weight, because it means the mechanisms driving this problem are not fixed in place. They can intensify depending on what happens with global temperatures in the coming years and decades. This is the point in the story where the mystery finally comes together. It started with a simple question: why is this one glacier called the Doomsday Glacier? Then came the correction, that it is not just melting from below like people assumed, it is fracturing from within even faster than the melting alone would explain. Then came the bigger discovery, that these two forces, cracking ice and swirling warm water, are feeding each other in a loop that is accelerating rather than slowing down. And that brings us to right now, this year, watching as researchers say the last natural break on this entire system, the eastern ice shelf, is genuinely likely to break apart. Not as a distant future possibility on a chart, but as something scientists are actively watching unfold in close to real time, using satellite data updated regularly. We want to be clear about something before we wrap this up, because it matters more than any scary number in this whole video. This story is not really about ice. It is about how carefully watching small changes, cracks nobody could see with the naked eye at first, warm currents nobody could feel from the surface, let scientists warn the rest of us years before a bigger problem arrives. That early warning is not something to be afraid of, it is something to actually be grateful for, because it gives coastal cities time to prepare instead of being caught off guard. The real lesson here is not that the world is ending, it is that paying attention early gives people, cities, and countries the chance to adapt before a slow-moving problem becomes an emergency nobody saw coming. That is the entire value of science like this, not to frighten you, but to give everyone enough time to actually do something about it. Every crack these researchers spot years in advance is really just extra time handed back to the rest of us. Time to plan, time to build smarter, and time to protect the people and places we care about most. That extra time only matters if we actually use it, which is why stories like this one deserve a calm, clear head rather than a scared, scrolling thumb. A crack that started as a hairline scratch in satellite photos 20 years ago has grown into a story that touches coastlines on nearly every continent. And it took patient, careful scientists willing to travel to one of the harshest places on Earth to make sure we found out about it in time. That kind of quiet, persistent work rarely gets the credit it deserves, but it deserves ours tonight. Thank you for sticking with us through the whole story today. This is exactly the kind of topic we will keep tracking as new updates come in from researchers on the ground in Antarctica. Subscribe if you want to be here the moment this ice shelf finally gives way, because when it happens, we will break down exactly what it means, calmly, honestly, and without the panic you will find everywhere else. Until then, take care of yourself, and we will see you in the next one.